From Karthik and MPU from the Anshu, now let's hear best of both. So basically from the overall perspective, right, TI portfolio perspective which we started with, we will be covering the Sitara AM2X MCUs. And as you can see here, right, it comes after the Hercules TMS 570 MCUs, which many of you would have heard. It has been to the space, it has been to the moon, as well as it has been used in a lot of ISRO missions. So we are a youngest and most beloved product line in the processors portfolio. We started in 2021. The first device came out in mid of 2021. And in fact, a lot of work actually happened during the COVID. So once you hear Artem's first Bangalore visit story, you should also hear our hardware director telling how he put team together and all. Believe me, we are tired of hearing it many times. Our happy hours are not happy anymore. So, okay. So getting into the what Sitara AM2X MCU is. So if you see from the overall the mega trends in the industry, right, if last 10 years plus, overall the processing needs at the edge has been increasing. So earlier we had Jacinto class devices or more actually doing the processing, and you know the MCUs were doing mostly the sensing part and passing the things to the processor for taking the decisions and all. But given now there is a higher processing needs, you know the MCU has to be also high performance. So what Sitara MCU brings here is actually, you know, the best of both worlds. You know, from the traditional MCU perspective, you know, it brings the safety, security, real-time peripherals, very advanced, you know, control. And from the MPU point of view, it brings the high performance, you know, RAM and DDR as well in some of our devices, signal processing like Edge AI, DSP accelerators, and advanced networking. So what we did in 2021, we realized there is a very high processing needs at the MCU. So we put together best of both, and you know, there you have the Sitara AM2X MCU. On the investment vectors, this is pretty much common across, you would have seen in the Jacinto as well as the Sitara MPU. So pretty much the scalability you can see right from all the three presentation you had. So the focus actually is on the enabling higher performance, higher control, higher communication at the MCU end. So basically avoid the traffic, you know. Okay, little bit zooming into the subfamilies, the product families of the AM2X MCUs. As you would seen, right, and as already told, the AM2X combines the performance, ease of use, system level integration, as well as it brings the scalability. So you can start with, like, you know, Artem was mentioning, you can start with the MCU and now, you know, you have to integrate more. You may need a Linux, HLOS, so you just move to the Sitara MPU. Now, again, further higher processing needs, you have a Jacinto. So the common SDKs across the RTOS cores, because as you would have seen from the block diagram, basically each of our processor has a RTOS core, Cortex R5 and going forward the others. So basically the same SDK runs on those RTOS cores. So your investments would be more on the HLOS, and you can take all the work you have done, you know, on your RTOS cores, MCU cores. So we, on the MCU side, we have three product families or sub-families, if I call. One is the AM26X, which is, you know, for the real-time control. And many of you, I can bet, you know, many of you would have heard about our C2000 product family. You know, you would have done the college projects on that. So what AM26 does, it takes all the best of the C2000, higher end, the control system, and you know, it puts the arms together for that. So basically you get the best of open source systems, open source ecosystem around the ARM for your host functionality, and you have a greatest processor for the real-time control, you know, C2000 control system. So that is the 2.6. We have a higher end analog integration and the control peripherals from the C2000. Then we have the AM24 family, where, you know, we integrate the advanced communication, like, you know, switching, as well as the integration. So from the differentiation point of view, we have ICSS, which is our industrial communications accelerators. There is our integrated multi-port Ethernet switches and all the needs for the communication info. The third in the line is the M27, and again, this is like one of the best ARM plus DSP combinations. You would have heard about TI from the DSPs. So we bring ARM plus DSP in the MCU, and it also has some radar accelerators. So for your audio and radar processing, we have the 27 family. So from the roadmap perspective, I'm not planning to go in detail here, but these are the devices from each product family available today. You can get started here. So on the 2.6 family, as I said, we have advanced control there. This is our real-time control family. So we have two devices out there today. The AM263X, which was RTM pretty much 1.5 years back, and the AM263, which APL like just few months back. So basically, these two will be ASIL-D compliant devices, SIL3 compliant. The 243, which is on our networking side, which has almost 6 ports if you combine the ICSS as well as the standard Ethernet. And the 273 is for the signal processing. And on the right-hand side, you see, right, these are the differentiation. And again, these are common across, so I don't need to repeat. So reliable, safety and security is a table stick. So if I say this is a differentiation, then I don't think that would be the right thing. So all these devices are ASIL-D, ASIL-B compliance, and low power. Okay. So basically, from the demo side, I'm not again including the 2.4, 2.7. We had some demos here on the 2.4, but I just want to zoom a little bit into the AM2.6 side of processors. So if you see the driver, basically the car chassis, right, and with the electrification, the digital power needs, the computational needs are on higher side, right? And earlier you had this architecture where host and control was kind of separate. You used to have like a Hercules kind of devices for the host, and the C2000 was doing control. So as I said, we are bringing the integration to enable the BOM cost saving, right? So this device starts from single core all the way to 4, and then you have roadmap devices which will go all the way to 8 to 10 cores. So putting across on the car chassis, you can see the different digital power application. We have DC-DC converters. Then there is a battery management system from the MCU side. We had on the MPU side, which will actually talk to the charging station. The OBC onboard charger. So these are all applications from the digital power perspective, and you can see this, actually there is a 263 device. We have a lot of good customers actually using it. One customer, largest in America, actually has gone to the production just some time back. So you would be imagining which one it would be. And on the traction inverter side, where there is a higher memory needs, higher host needs, we have the AM263P. So quickly going into the demos, you would have already seen here. So you saw the AM263P resolver demo, the digital converter. So that's out there. It will be there during the lunchtime. You can go and see. On the 243 side, we had 2 demos, and again, the story is consistent. It is the integration. So from the encoder perspective, from the motor control perspective, so this demo actually shows the multi-channel position sense, like ability of AM243 to run the multiple absolute position encoders, as well as do the motor control. The third demo we have here is the IO-Link gateway. So industrial Ethernet to the IO-Link communication. So again, this is also available. I think that's all from my side. The QR code takes you to the Citara MPU, but that's because the organizer was from Citara MPU. But you can ask questions for the Citara MCU as well. Thank you.
Can we have a big round of applause for our speakers? All right, so for the next 5 minutes, we're going to have a Q&A session. So you can ask anything that pops up to your mind. Please don't hesitate to ask questions. So if you have a question, you can raise your hand and our team will hand over a mic to you.
Hi. There was a part in the presentation on the software-defined vehicle. Is there any flyer or demo for that?
So the question is on software-defined vehicle, and you wanted some information on that?
Yeah.
So I'd encourage you to check out the DRA 821 and DRA 829 portfolio of devices.
Okay.
I can, when I speak to you later, I'll point you to the resources.
Sure, sure.
So we have some enabling pieces for the software-defined vehicle. And in terms of investments that we're doing to move in that direction, there's some more things that are coming up. So I'll point you to the right resources from where you can start looking at things.
Sure.
Thanks.
Thank you.
HL, yeah. I would like to ask one thing that the current set of Sitara processors, are they also suitable for railway applications? I mean the railway signaling Kavach systems, okay, or the driver resistance systems or TCMS systems, train control management systems of Indian Railways are getting upgraded now. And many tenders are getting released, and bigger players like Alstom or BHEL or ABB, we are moving forward in the development of systems right now. So we are looking at subsystems and also especially Kavach. A lot of 6,000 kilometers order is going to come, and I'm also looking for Sitara processors, whether they are suitable or not, and regarding that we need a lot of help from you.
Yeah, so I will answer from the MCU perspective because you covered the multiple applications, right? The Kavach, I would believe, is the camera applications, right?
Yes, yes.
So yes, both Sitara MCU as well as MPU you could use in the railway applications. In fact, we are engaged with one of the very important tier one on the railway side, which works with the Indian Railways. They are using our AM2X family of processors. So yeah, you could use it. If there are motor control applications, you could use the 2.6 or 2.4 family of processors.
And also now they are moving towards wireless networking. Kavach is actually working upon GSM, GPS, 4G, LTE. Now they want to plan for 5G also in Europe and here. So maybe I think one of your processors should be much more suitable for us, and you can propose those things too.
Yeah, we can probably discuss more offline, but basically you saw, right, we have microcontroller processors. Okay, please go ahead.
Yeah, maybe I'll let you finish your thought, then I'll just tell something interesting.
Yeah, so we have microcontrollers as well as we have a separate business unit which is for wireless. So we already have a demos where we have put together this microcontroller and the Wi-Link chip, so which also can be utilized.
Sir, if you already have an architecture in mind, or if you want to have a discussion, we are enabling some clients with something similar to what you are discussing with the AM263X that you mentioned. I understand that would be a cell 4 kind of application, so you would need
Absolutely.
two of these together, sitting outside and monitoring each other, probably have FSOE also to connect to your main domain controller. So we can discuss this later on with some more time.
Thank you. Thank you.
For LPDDR5 and above, do you have some scalability platform on that?
Yeah, so the Jacinto processors are currently supporting LPDDR4, and we are constantly updating our roadmap with devices for the future. The next set of devices that will come will definitely support the technology that is more suitable at that time. I'm specifically not able to comment on LPDDR5, so LPDDR5 definitely is not supported on Jacinto. The devices that we talked about right now, they're more for LPDDR4. For DDR5 will be a future device discussion, but it will definitely come. Yeah.
Series, is there a display interface available? And it's what kind of display interface?
No separate display subsystem as such, but we have customers using the traditional SPI-based or the other peripheral-based display subsystems.
Not anything specific, right? Like so, MIPI or LVDS?
Not it, I would say.
Okay.
Yeah.
Yeah, I see like 5G integration, like 5G module integration or something, but something very specific like.
So I think you meant 243 or the
243,
AM64, which has a high-end gigabit Ethernet subsystem as well as the PCI. So these are more for the high-end networking, where you would be that kind of domain controller application Karthik was showing, right? So where you'll actually connect two chips and then connect them via PCI, and they will communicate the data across. Do you have a...
So the SDKs will support whatever is there on the EVM. And so in the slide on the domain controller that I was showing earlier, there will be a PCI connectivity. So taking a step back, right, the SDKs will support the EVM configuration. The EVM just has one device, but it allows you for a PCI connectivity. So when you design your board, you can take advantage of that. But the SDK as such will not work on two devices. That's something that you will have to integrate on top.
PCI, how the software, whether it will be a custom communication made or there is something which is already. Sorry. So I want to ask, like, in a multiprocessor model, right, where we are connecting a MPU for more like video-based system or HMI-based system, but for a real-time operating system, we are connecting a MCU, say Sitara. And we are using PCI as a general or any other interface as a general for connectivity between the processors. So one way is like having just a custom communication which an application or the developer make it to make an interprocessor. Is there something which is by default available for interprocessor communication and interfaces which is recommended by TI?
Yeah. So I think this is a very common use case you mentioned, right? If you see, we have a M64 family of devices, and then there are 243, which is a microcontroller. Now, a lot of our customers actually put these two together because the M264 brings the Linux, and the 243 is a motor control. So basically, out of box SDK, we don't provide the example where both will work together, because PCI being a standard, and we support standard all configurations, right? So even if you put together, it will work, and that has been happening. So there should not be any issue with the getting started.
Sure, thanks.
Application nodes in the past which allow you to take two different devices, connect them over PCIe and communicate, but then they're enabled by two different SDKs and an application node stitching them together. Those resources are available on ti.com.
Wonderful. So always remember, all of us on time for tea break. You can find anyone who's wearing a red badge and you can fire them with your questions. So as the morning unfolds with the brilliance of our speakers, let's take a delightful detour for a tea break. It's a moment to recharge not just your batteries, but also to appreciate the aromatic symphony of tea molecules colliding in hot water, something akin to the dance of data flowing within our favorite processors. While you enjoy your tea, don't forget to take a stroll and marvel at the cool demo setups waiting to be explored. It's like a playground for a tech enthusiast, where gadgets come to life and semiconductors show off their groovy moves. Sip, savor, and venture into the world of demos. Your tea break just got a little more tech savvy. Like I said, we all TIers are wearing a red badge. Please fire us those questions. We love answering you. As well as that, there are demos who have not yet seen. You can check out a lot of TI demos here. There's also AI demos from TI, which is right outside this hall. There's also ecosystem partner demos in the room beside it. So you can all go check out that. And now we can all get up for tea break. Thank you. We'll all convene
if
back.
I get a minute, sorry, before I break. Hello. If I get a minute, yeah. So for the PCI, I am Vasu from Phytech. So we are the ecosystem partner for TI. So for the PCI, the host and the device interface, the PCI interface will support the root complex on the host side and the endpoint configuration on the other side. So the driver configuration to be needed, and there is a multiprocessor architecture is a different, which is a like asymmetric multiprocessor or OPM, standard Linux frameworks are there. On top of that, you have to integrate the drivers, basically. So when, as such, the PCI drivers are more generic, so you have to design some driver architecture for that. Thank you.